Problem number 2. How many 5-digit positive integers have at least one zero? Alright, so what does that look like? We have 5 digits, okay? And one thing you've got to know is that to be a 5-digit number, this first digit cannot be 0. Otherwise, it would be a 4-digit number, unless the fourth digit is 0, and then it would be a 3-digit number. So this cannot equal 0, all right? And it really doesn't matter what all the other ones are, but in order to be a 5-digit number, the first digit cannot be 0, okay? So, all right, so we're asked to find how many 5-digit positive integers have at least one 0. So it could have 1 0, 2 zeros, 3 zeros, 4 zeros. Can't have 5 zeros, that won't work. But so like 50,000, 50,000. That's a 5-digit number that has at least one 0. But what I want to do to solve this one is count the complement. Okay? The complement with an E, meaning that it's the thing that completes it. So if we took all of the 5-digit integers from what? From 10,000 all the way up to 99,999, and then all of those numbers have to fall into two categories. They either have at least one 0 or they have no zeros. Okay, so the complement of having at least one 0 is that it has no zeros. And it's actually easier to count the number of 5-digit integers that have no zeros than it is to count all the cases where you've got either 1 or 2 or 3 or 4 zeros. Okay? So let's do that. Let's count the complement. Let's count how many 5-digit numbers have no zeros. Alright, so again we have 5 digits, and what are our choices for this first digit? We can choose the numbers 1 through 9, right? So we have 9 choices for the first digit. And then if we're counting the ones that have no zeros, then we have 9 choices for the second digit, so just 1 through 9. We can't choose 0. 9 choices for the third, 9 choices for the fourth, and 9 choices for the fifth. So we have 9 to the 5th ways of getting no zeros. And but that's the complement, okay? 9 to the 5th. Let's actually calculate that out. 80. Essentially 9 squared is 81. So if I take 9 squared times 9 squared, that'll be 9 to the 4th. And so let's take 81 times 81, and 0, 8, 6, 4, 1, 6, 6, 5. Alright, that's 9 to the 4th. So we have to multiply it by one more 9. 9, that's 54. 45, so 45, that's a 0, that makes it 50, 54, 59, okay? So this is the number of ways to have no zeros, 59,049, okay? Now we want to figure out how many have at least one, alright? So basically what we need to take is the whole and subtract 59,049. So how many 5-digit integers are there total? There would be, well, we'd have 9 choices for the first digit, right? I guess we could use these same digits. But for the last 4 digits, we'd have 10 choices because we could include 0, right? So 10 choices for each of the other ones. So that's going to actually give us 90,000. Okay, so there's 90,000 5-digit positive integers. And 59,049 have no zeros. So how many have at least one 0? Well, we can take 90,000 and subtract 59,049. we get? We'll get 1, 5, 9, 0, 3, right? Because this would be a 10, this would be a 9, this would be a 9, this would be a 9, and this would be an 8. Okay, so yeah, that works out. Alright, so this number is what we were actually looking for, which was the number of 5-digit positive integers that have at least one 0. Okay, so we used complementary counting. It was easier in this case, rather than to count the number of ways we could get at least one 0, it's easier to count the ways we could have no zeros and then subtract that from the whole. So this was our calculation for the whole, which is basically the number of 5-digit positive integers total. Okay, so 90,000 minus 59,049 gives us 30,951. So there you go.